It would be harder to better Davide, but I'll try to. I don't know if you ever felt like the guy in the picture, which I believe you know of. I know I did several times, but among the several reasons in the lifetime you can have for feeling like that, for example, I'm a father, I feel like that every day. We are in at an MLOps related talk, so we can guess we're talking about MLOps, which struggles to keep the development and production together and brings them closer. Well, actually, the first thing I thought when I got into machine learning wasn't really the smartness, the cleverness of the models, but it was I was baffled about how hard it was to make these models come to have real values for the companies. So I believe many of you, if you're here, know the struggle we face every day about MLOps, but let me just do a brief recap. From one side, we have the team of the data scientists working on notebooks, usually with Python. There are still some R fanboy, but we're not many. And well, when you're working in development, you usually have several data, and you want to work with batches. And well, the speed is kind of a nice to have when you're develop, since you can work on and train on the models for days. On the other side, you have the team of developers that struggles to keep things fast, builds microservices, make them interact. You usually have either one single prediction online or, well, at least smaller batches. And well, actually, these teams don't even speak the same language. Usually, the developers don't even speak Python. And even let's say, the competencies and the vocabularies are different. You have the data scientists with their background as mathematicians, and the developers are, well, developers. There's a big rift right there. And some think that to solve this, the better things to do is putting notebooks into production. Well, no, that's not what we think. And well, it's almost a meme to say it. And because notebooks thrives in chaos, and we don't want to put chaos in production. So why would you even care what I'm saying besides my beautiful broken smile? Well, disclaimer, which I don't think will help. I don't know anything about machine learning. Not really, but I'm surely not a machine learning engineer. Davide, for those that were here before, knows a lot more than me, and the others in the team too, more. What I am is a developer. I worked with Python for several years, 6 actually. And I know all those buzzwords are like software architecture, clean code, design pattern, solid principle. Those are the things I know of. And also, besides Python, also other languages, because I like them. And what I'm doing right now is the engineering manager of the analytics and machine learning operations in Prima, which is a team dedicated to machine learning operations, among other things. If you never heard about Prima, well, we have a stand downstairs, and if you watch television, is the one that goes, Come Prima, più Prima. Yeah, that. I'm not a great singer, I know of, but that's it. We are an insurtech. We sell basically insurances mostly for the motors, but what we do good is technology. We are really leaning on technology for doing our stuff. And our problems are mostly in real time. So for example, for a recommender system, I never worked in Netflix. Maybe I will never will. But if I were there, I would have the features and the predictions evaluated offline, because you know your user, you know your data, you have everything you need before showing the prediction to the user. What we do instead is having the user coming to our site or to some price comparison site, probably, you know, Facile, Segugio, those guys. And, well, they give us those data, which we can't even trust so much at runtime. So when in the background several microservices are launched, we have like 20 that wakes up every time someone give me the price. And among them, there are several models launched for scoring, behavioral, fraud detection, and these kinds of stuff. So we need to be fast. If we are slower than benchmark, but we decided being 3 seconds, if you go to facial execution, it's actually something more. But, we need to be fast. Not Hadron Collider fast. We're not speaking about microseconds, likely, but it's in the hundred of milliseconds. So we can't use everything that can be used for batch predictions. So what are we doing about it? I bored you enough with my introduction, but I want to clarify one more thing. There are not best practices right now in MLOps. I don't know if it is because it is too hard to do, or because there are so many different applications, or just because the practices are too young for it. I just share some laws about things we've done, what we learned, these kinds of stuff. I'll focus on collaboration and features because those were the most important for us, and I feel they are kind of underestimated too often when speaking about machine learning operations. So, the first things I want to talk to you about is how to close the gap. And the main gap that there is, at least to my point of view, is between the data scientists and the developers. So we decided to have them work together. The data scientists in Prima works close to the developers when deploying the models, and on the other side, the developers works closer to the data scientists when they need to develop their models, which is fundamental because we immediately noticed an improvement not only in the time to get a model to production, but of the quality itself in the model. What I want to express is that MLOps should begin at development time, not just, I have this model ready, and now you can put it into production. That's a bad practice. I'm quite sure of it. I don't know best practices, but the bad ones, yes. And I'll let you notice also that I'm not speaking about MLOps engineers. I speak about developers in general. And I'll let you figure out why. What are the advantages? Well, the first advantage, besides what I already told you about, are the capability of the developers to notice early blockers. I don't know if it ever happened to you, but those guys over there are actually responsible of coming to us, I'm a developer, asking for a feature maybe to be put into production, and maybe comes there saying, well, we kind of need it in the next few days. Okay, it will take kind of a couple of months to do. I think that's an issue. And having the developers involved in the development of the models will help because you have those people knowing how hard it is to do stuff and to put it in the real world when you need it. You can avoid doing stuff, or you can decide to start acting earlier on, developing whatever you need. These are fundamental. And on the other side, the data scientists are empowered, to do whatever we want. Well, not whatever. We still need to do PRs and have someone to approve them. But they can act on the actual microservices we have in production. They can read that code, understand what happens in production, and change that themselves. They are not able, usually, to start from scratch, but they can do changes. Maybe small one, but they are needed for our business. And the last one is, I already mentioned it, but it is empowerment. The empowerment comes from the, let's say, contamination you have between the developers and the data scientists, because they really have different competencies, but they kind of need both competencies. So you have the data scientists being empowered to do more with what they know, being by themselves. They can do better notebooks, they can do better toolings, and the developers can build tools, stronger tools, more efficient tools for them. Of course, you might guess that's not everything always good. So there are some catches. I think you'll be surprised. But, the main ones are the ownership. If you always have two people working on the same stuff, you never know who should you go for, asking for changes, to insights on what happened. If you need two people, you need to hire them, which is usually not a kind of salary issue, because the models, well, they are much more important than true salaries, but you need to train them. It's hard, it takes time, and so on and so forth. And you need to use Python, which is, here, I don't think it will be kind of a problem, but many developers don't like Python, don't like to put it into production. There are several problems I think we are aware of, and Python is, in general, not the best language for everything, so I think we can admit it between us. So what we decide to do is trying to clarify a little bit more the ownerships, but it will always be a gray area. And especially we decided that the microservices that needed to be in Python are only those ones that the data scientists need to be able to change. That's kind of how we got around it. And well, that's it, kind of. You might think how well it performs with us. I can recommend it for businesses that are from 0 to like 40 data scientists and, well, developers, because related to machine learning and data analysis, obviously, you need much more developers for the other stuff. And then sure, that works because we're making it working in Prima. What I have some doubts about is how it can grow up for bigger teams, probably, maybe not the next year, but in some times I will come here saying we have found a better yet way to do it with bigger teams, but until you are small, do it. Well, try it at least. And now that I bored you a lot with talking about peoples and so on, well, we are at a tech conference. Maybe you want to also talk about that. And as I mentioned before, the thing I want to focus on are the features. Features are really important for us. Well, it should be important for everyone doing machine learning, also to even just deciding which one to use. But, well, let's do a brief recap for those that don't know, since it is a beginner talk. What are features? Well, you usually have some raw data. Like for a vehicle, you could have the vehicle type and the year it's been produced. And maybe, just maybe, if you have something in common with us, you want to create a risk model which gives you the price to show to a user. So you usually don't use the raw data and make them in some better representation. So for example, the year is better represented by the age of the vehicle. Basically, it's the same information represented in a different way, but it is important to represent it in a different way because the next year you have this raw data that have the correct age, for example. Even the type of vehicle, you can decide to not encode it. You could even decide to have several models for each different type of vehicles, and so on and so forth. And it is kind of simple. If this was the world, the problem is the real world it's more like this one. You have hundreds, if not thousands, of features, what we have, and you have tens of sources of data, maybe the same data represented in different ways from different sources, and they don't even agree about it. So it becomes complicated, and especially it's difficult to have it in production because you need to keep consistencies between what the data scientists defined in their own notebooks to be a feature, to be an encoding, to be whatever, and what happens in production, in the microservice that will serve the model. And usually not even the data scientists agree about a feature. So the first thing we did was actually trying to do that, to make data scientists agree about what a feature is for each kind of representation. You can even specify age. You can define it in like 10 different ways, and they did. So what the first thing we did was building this library, which is called Seshat, that kind of brings them together. One single definition for the features used by all our models, which also helps communication between data scientists because then they know what they're talking about. And that's kind of important with 40 people talking. Well, the interface is quite simple. Have the users, the data scientists in this case, coming asking for, well, a list of features, and they go to this nice library which we call Seshat, which is an Egyptian goddess of knowledge. So the point is that the library knows what are our source of data, what are the transformations needed to make them data better for our models, and so on and so forth. Basically, it's a very fancy SQL wrapper. And, well, it's with that magic that happens behind the scenes, it will retrieve the features. This worked well for us for sometimes. It works well until your teams are small. You have not thousands of features, but until you are in the 100th one, it works well. So what we needed was something better, something faster to be implemented, and something that agrees also on what happens in production, which this doesn't. So we came up with this story of the transformers. Those are not the transformers you may know of, like Hugging Face, not the Decepticons, they're not those ones. And we started from a simple observation that, well, it wasn't really an observation. It was like, we need to put this into production, and it wasn't working at all. Usually in production you have some kind of dictionary. Well, you can represent the payload as a dictionary, we do at least. And you want maybe to replace missing values with known values you decided was good enough for it. And this is, well, the fastest way I could think of. Maybe you can think of better ones. And this is the language data scientists speak. So I tried to do the same thing in Python, which in a very simple way, because simple is better than complex. And I tried to measure their performances. I don't know if you ever tried to think how much faster is Pandas respect to Python, vanilla one, for these kinds of stuff. Well, I measured it with time IT. Just for this simple transformation, I repeated it 100,000 times, and it was 40 seconds. So what do you think might be a good time for vanilla Python? And I kind of thought it would have been better Python, because, well, Pandas is optimized for big data, not just one row. It's obvious, right? Yeah, it is, but it is much more than what I expected. Python is 1,600 times faster than Pandas when working on a single row. It uses better, the memory is used better, and does much more. I don't know if you ever looked at Pandas source code. It gives the headache. So, and we actually couldn't put into production some models because of this, because the preprocessing was built in Pandas. We kind of copied and pasted it to the microservice and thought it would have gone well. It didn't. And so we went study our user's notebook. We decided to call the preprocessing atomic steps transformations. And we noticed these things. Well, what happens in notebooks is usually the data scientist repeats several times the same transformation on several columns. I believe you tried it. And the transformations usually are not something much fancier than replacing, mapping, one-hot encoding, binning, clipping. Those are the transformations that are usually used, which are simple, and they are a few. And another thing, you may have a little bit of custom transformation for a given model, but they are little. And especially, it's not much important to the data scientist what happens behind the scene. It's noise in a notebook, seeing all those pandas replaced. You just want to know that value has been replaced. You don't know. You don't want to know why and how and so on. Well, why you do, but the how, not so much. So what we did was taking inspiration from sklearn transformation library, which is not very well known, but we created this other library with this interface. Basically, the user can decide on what column it wants to apply the transformation with a declarative approach instead of an imperative one. It can decide to apply the same transformation to several columns, and it can decide that maybe one transformation needs fitting. Usually you don't want to put that general Kinobi to replace a value. You want to fit the value to be replaced. So we allowed our user to fit this data, and once they are fit, you want to put them into production. So we have this save of, well, it's basically a YAML file of this transformation that can be put into production as it is and work as it is. So it takes like 5 seconds to do it. When you need to version it, it's not much more. So what we did is basically a DSL for those that like this kind of stuff. And one other thing that improved a lot is the notebook readability. There's nothing about the data frame. You don't even know that's a data frame, to be honest. It can be anything. It could be a PySpark data frame. It could be a Pandas one, Polar, Koalas, Flink. There are thousands, well, not thousands, tens of frameworks to do this stuff right now. And especially it can be vanilla Python. So do the thing won't work? Well, you may think. We have some models in production using this. It is still in beta, the library, actually. So this is more of a concept. But we're working on the 1.0. And well, the pros I already mentioned, so I won't get too much into it again. But the cons are there, again, surprise Pikachu. Well, first thing, you need to write the library. It takes a lot of time, I can guarantee you. And it takes a lot of testing to ensure that what you are, let's say, guaranteeing the user really happen, so that if I say replace, it will happen replace. And it will be especially hard because, for example, NumPy represents the none in a very complex way, and you need to guarantee that the none are replaced as none, which makes sense. Other things that is kind of a problem, is that this is a partial solution. It allows you to represent the transformations, but it won't involve the source of data like, well, seshot or how to serve them to the model. So what if it exists as something better? The answer is kind of obvious. And it is a feature store. We didn't invent it, but we kind of stumbled into it when we were asking us these questions. I don't know if you ever heard about it. It's kind of a recent concept. It's exposed the first time 5 years ago by Uber, so it's kind of recent. And it deserves a whole talk about it, but I'll just go in briefly about it. It allows you, it knows the data sources. So not only the offline data sources, it can know also other kinds of data sources, like on real-time ones, or you can pass data to it at real time. It knows, obviously, the transformations to be applied to this data, and it knows where to retrieve them. It allows you to store them. It gives you a nice user interface if you do it right. And then you can query it both online and offline. And what's really important here is that offline, it is optimized for throughput, and online for latency. And we didn't do it ourselves. We bought an external one. And well, it is Tecton. I'm not here to do advertising for Tecton, so I'm not sure whether it is the best solution for whatever problem you might have. Surely it was good for us, and there are a lot of competitors popping up in these frameworks. But what we found is that it really keeps its promises. It allows you to define just once. The data scientists are those that defines those transformations, and they are available to all other data scientists in the company or in the world. And if you are crazy about it, and well, it works. We are using it to launch new countries. We didn't replace our current infrastructure with it, but we're using it. And well, what else? There are a lot of things to say about MLOps. Sadly, that's not much time to say them. Usually people are very interested about the deployment, the versioning of the models, this kinds of stuff. But since there's no type, I keep it for myself. Well, obviously you can come finding us. We are downstairs, or you can write me. I'm very happy to answer any of your questions. And I think maybe there are some right now, hopefully.
Thank you very much. So here's the first question. Could you hear me, right? Yeah.
Yeah.
Could you? Here's the first question from the application we use. So do you have any plans to open source your C# library and Prima transformers?
Well, the session not so much because it contains basically all the definition of our features, so it would be hitting us in the knees ourselves. But the transformers one, we are thinking about. Sorry for my babbling. We're thinking about it actually, and we are doing it to be exposed to the world if it works well as like we want. Let's say.
Okay, thank you. And the second question is, how do you deal with the mutable nature of features, both in terms of definition of them and in terms of values? Example, the age is updated. What if I want its value a year ago?
Yeah, well, that's kind of hard as a question. For example, Session doesn't handle these kinds of things, which is one of the reasons we are leaving it for better fields. The promises of the feature store is instead of allowing you to do it. So being able to time travel with your data is one of the very promises. It's very hard to maintain and to keep. But yeah, you can do it. And from the sides, instead of the versioning of these features, it's another hard topic. What we decided is not to kind of version them as you do with Git, but let's say making variants. Well, it's actually one of the concepts of feature store, this too. So you just build vehicle age underscore V1, V2, V3. It seems like a bad practice, but if you do it in the code and then you have a nice UI in which you can see all the vehicle age together and you can go to each version, it's kind of a good compromise. So you'll be always able to query whatever version of the vehicle age you decided.
Yeah, also, they are called in data warehouse space slow changing dimensions or features maybe. So yeah. So next question is in real life. If anybody has any question? We have time.
I'm safe.
So maybe I can come up with one.
Oh no.
So, okay, well, the first question would be on the name of the Prima transformers. So you put your company name in the name of the open source library.
Well, no, actually not. It was just to say these are our custom ones. It's not the scikit-learn one. We will, if we release it, it won't have the Prima probably in front of it.
You plan to change it before the version of the release 1.0. And what else? Okay, I mean, I'm okay. Thank you, everybody.
Thank you.
Thanks to Lorenzo.